Good day everybody, my name is Layderos. I'm from Camarines or Polytechnic colleges. For today, I'm going to explain our created searching and binary search program. So the first program is the searching, one of the example of searching programs which is the thieves to be caught by the police, and the second program is an example of binary search which is the playoff. So for the first program, this is a searching program. A policeman can caught a thieves. So the program is a linear search titled Policemen and Thieves. So the program is designed to find the maximum number of thieves that a policeman can caught in a row and in a row in a grid. So this program code includes the iOS stream. So we add this for the standard input output of the program to read the cin, cout, and others. And the namespace std is actually vital, or you can see this in every C++ program to generally include all the program in this std. So here we declare and assign the int as data type for the number of cases. You should not include number here with a decimal point because test cases should be a natural number. So test cases could be 1 or 2. It depends on you in the problem. And we also assign and declare the n, which is n is the number of the matrix or row by column. The matrix, it depends on you if it's as 7 by 7, 6 by 6. So if you choose 6 by 6, 6 should be enter or papasok sa n. And then the k is the distance of the police to the thief. So this is the units away of the police to the thieves. So here we initialize the thieves that a policeman can cut, so it's 0. It's not assigned or it's not fixed because the program, upon running the program will ask the user to include the policemen and thieves, and then the program will analyze and search all the thieves that a policeman can cut. And here we also assign and declare the thieves caught per case. It depends on the number of cases that you will insert over here. And this is the for loop of the program where the grid is a 2 by 2, I mean a 2-dimensional array, so that we can store values of the police and thieves in row and in column. Okay, another a for loop where the row should be equals to 1 and the row should be less than n, because 0, the row will always less than n because n is the number of matrix, which is equivalent to 1 to any number you want. And the row will be increment as the number or the value of n adds. And then we will enter or insert, itatapon natin the grid. It's the matrix, the size of the matrix here. And then the program will do the magic here, where the program will rely on this algorithm and solution to show and search for the possible thieves that a policeman can caught. So to show that a policeman can caught a thief, so we will run test cases here. Alright, these are the test cases. So for example, we enter 1, the other line is 3 and 1, following with the police, thief, police, thief, police, thief, 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 and police. So before entering and revealing the output of the program, so let me introduce this. Number 1 is the number of test cases. So I think we have to enter number 1 as the test cases where one test only, so that it's not confusing. So the number 3 here is the size of the matrix or size of the grid. So 3, it means 3 by 3. And the 1 is the K of this grid, where 1 is the distance of the police to the thief. This is the units away, the K units away from the police. So in this, the output is 3 because policemen can catch a thief and at the same time reach a thief. A total of 3 because, for example, in this row, yes, we have 2 policemen. However, we only have 1 thief. Yes, these 2 policemen can reach and can catch this thief. However, since the thief is only 1, so in row 1, we have 1 thief to be caught by a policeman. In row 2, it's still 1 thief can be caught because this policeman can reach the thief in the left and the thief in the right, since a policeman can catch 1 thief at most. So 1 thief can be catch in this row. And in row 3, same with row 2, we only have 1 policeman here. So in this scenario, the policeman can only reach this thief. The other one is not, because we only have 1 as the units away of the policeman to the thief. So only 1 thief can be catched by a policeman. So in totality, 1 in row 1, 1 in row 2, and 1 in row 3, we have 3 thieves that a policeman can caught in this test example. So testing another example. For example, we have 1 as test case. 5 is the size of the row. Five is the size of the row. 1 is the distance or units away of the policeman sa thief. So we will enter here a series of policemen and thief. 5 policemen per row. I mean a 5 by 5 matrix. So for example, P, T, P, T, P, T, T, P, 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 T, P, T, 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 P, T, T, P, T, and T, T, P, P, P. Alright, so by the way, the P stands for policeman and the T is thief. So in here, the output is 7. It means a policeman total thieves caught is 7. So for example, because in row 1, we have 3 policemen and we have 2 thieves. This police can reach this thief, same with this police can reach this thief, and same with this police, it can reach this thief. However, in this row, the 2 thieves can be caught. So in row 1, we have 2 thieves to be caught. In row 3, we have 1 thief to be caught because this thief cannot reachable by this policeman because we only have 1 as the distance or the units away. So this police can only reach this thief. So in row 2, we have 1 as the thief to be caught. In row 3, since since policeman is only one and this policeman can reach this 2 thief but can catch at most 1. So in row 3, we have 1 thief to be caught. In row 2, this policeman can catch this thief. This policeman can also catch this thief in the left and this thief in the right. In total, but policeman can catch thief 1 at most. So in row 4, we have 2 thieves to be caught, and in same 3 and in row 5, we have 3 policemen and 2 thieves, but only 1 thief can be caught, because this policeman can reach this thief and can also catch this thief. So the total thief for these rows in totality is equivalent to 7. So inserting another example or test cases. So 1 will be the number of test case, 4 is the size of the row and is the size of the grid or the matrix. The 2 is the K or the units or distance of the policemen to the thieves. And assign the series of policemen and thieves PT, TP, PP, TT, TPPT, TPTP. So in here, we have a total of 8 thieves to be caught. In row 1, we have 2 policemen and 2 thieves. Since these policemen can reach these 2 thieves, so in row 2, the policemen can caught 2 thieves. The total of thieves that can be caught is 2. And row 2 is only 1 because this policeman can reach this thief and this thief, but since he can catch at most 1, so we have 1. And this policeman cannot so the total number of thieves that can be caught is 8. So another example would be 1 as the number of test case, 7 is the size of the matrix, and 3 is the units away of the policeman to the thieves, or the distance. We will insert the TT, PP, TTP, PTT, PT. So in here, we have a total of 20 thieves that a policeman can caught. So the units away is 3. So this policeman can reach these thieves, this, and this. So in row 1, we can say that the total of thieves that this row can caught is total to 3 because this policeman can reach this first thief here. This policeman can also reach this thief considering that the distance is 3, and this policeman can also reach this. So since we have 3 policemen and this policeman can reach the 3, so in row 1 the thieves can be caught is 3. So in row 2, so I think we have to count the number of policemen. So the police in this row is equivalent to 3 and the thieves is equal or greater than policemen. So we can say that we have a possible of 3 thieves to be caught. But we have to justify that. So this policeman can reach this thief. So we have 1 point. So we have so this policeman can reach and catch this thief. Same with this police. Since this police can reach this thief, so we have now 2, and this police can also catch this thief. So we have 3. So the process is same idea, same algorithm in the following rows and matrices here. So the number of thieves can be caught is 20. So now we may now go to another problem, a binary search problem. So this is a playoff. So the program is tasked to find the number of teams that have a non-zero probability of making to the playoffs. It is a football championship with teams that are competing with each other on the league stage. So in here, same with the previous program, we just assigned this include iOS stream, the include algorithm. The include algorithm is for the functions to be used on ranges of elements. Since this program has a set of elements, ranges, and matrix, we should include the algorithm. So in here, again, we declare and assign test cases. So this is where you will include an integer number of how many tests you want, where here we assign a while loop where declare the n as the number of teams. The second is the m, or the remaining days for the playoffs, and k is points that the team gain per day, and the b, the last last place or location of the row, is the teams that are automatically have a non-zero probability to playoffs. Okay, we have to tap on the variables here, the n, the m, k, and b. So we have these parameters or the for loop for the program to do the magic or solve and search for the playoffs. And we also use an if else for the maxi and mini, where maxi would be equal to mid and the mini will equal to mid but will be incremented or added by 1. So to run this program, we have to insert test cases or example for the binary search in playoff. So for example, we enter 1 as the test cases, 4 as the size of the matrix, 4 as the size of the matrix, the 2 is the days left, and the 2 is the 2 points per day, and the 1 is the team that is qualified for playoffs. So for example, team 1 has 4 points, team 2 has 1, team 3 has 2 and team 4 has 3. So here, the output is 3 because 3 teams are qualified because this team has 1 score, so 0 probability. For the team 2 is not qualified, so we have team 1, 3, and 4 is the qualified for the next playoff. So another example for this program is, for example, 1 test case 4 1 1 3. So team 1 has 4 points, team 2 has 4 points, team 3 has 1 point, and team 4 has, for example, 2 points. So the output is 4 because here it doesn't have 0 chance because this team can tie up with B, which is 2. So they have still a chance. So that's all. Thank you for watching. This is the searching and binary search program.